right, and now it's a great pleasure to welcome Lars Wemme here in our virtual studio, who is the Vice President for IoT Security at Infineon Technologies. So welcome, Lars. Thanks for taking your time and for being with us today.
Thank you very much for having me, Andreas.
So Lars, 5G is sometimes promoted as the network of all networks. Will it live up to its promise, or is it all just a hype?
The deployment of 5G and the move towards cloud and virtualization are reshaping operations and practices across industry. Analysts predict impressive growth for communication devices and machines using 5G network. The transition is being rolled out with the purpose of having faster and more reliable cellular communication combined with the capability to also connect network-constrained devices on a public or private network. If we take the example of a manufacturing plant, this 5G network of networks will enable the connection or interconnection of battery-operated smart sensors, mission-critical edge devices, routers, automated guided vehicles, and cloud servers. The deployment of such a broad variety of things is attributable to new 5G features such as multi-network slicing and multi-connectivity networks. It's now clear that 5G technology supports billion of devices and meets industry's most pressing demands: scalability, ease of deployment and wide coverage, cost and energy consumption efficiency, data capacity and transmission speeds. But by delivering the required agility and economies of scale, 5G is also significantly changing the attack surface for attackers as the number and diversity of connected things rises at speed.
So that brings us on to the topic of security, which is always very important, of course, particularly in the manufacturing industry. What are the special threats that 5G has to face, and how can we deal with them?
This new and broader attack surface greatly increases the scope of potential threats relative to the risks that preceding 2G, 3G, and 4G generations faced. This includes the risk of data manipulation, denial of service, device tracking, spoofing, eavesdropping, and piracy. In other words, an attacker may prevent a user from entering a building or could expose or manipulate confidential or mission-critical data while it's being transferred to the cloud. The more complex the device, the greater the risk of attack, but also simple devices such as coffee machines or smart light bulbs serve as an entry point for attackers. This means that a high level of security is necessary across the board and irrespective of each connected device resources. The good news is 5G now incorporates the security controls required to address those threats. 5G has the security capabilities to protect subscribers, devices, and their communication, but also the integrity of the network itself. Security can be achieved through mutual authentication of devices and of the network, as well as through the encryption and signing of data traffic.
Yeah, great. Thanks, Lars. That's very interesting and insightful. I'm just wondering, what role does the SIM play in all of this?
The role of the SIM is to establish a link between the final user or device and the mobile network operator, and, in the end, to enable the connection to the cellular network. The SIM stores credentials such as network keys and unique numbers to identify and authenticate the device that consumes the data. The SIM is based on proven technology and has been successfully deployed for many decades now. Comprehensive standardization provides interoperability between the various providers and operators across regions.
So how do 5G SIMs and eSIMs in particular contribute to security?
SIMs have evolved in the same way as core network architectures to meet evolving security challenges. Thanks to its new architecture, algorithms, authentication policies, and protocols, 5G SIMs play a pivotal role in meeting the high security standards required across all device types. Regardless of whether a device connects to the network continuously to exchange gigabytes of data, or it connects only from time to time in order to exchange a few bytes, 5G SIMs provide the required level of security. For devices that have a projected lifespan of 15 years, over-the-air provisioning and firmware patching are additional key capabilities. Modern SIM implementations use powerful 32-bit security processing cores along with hardware crypto accelerators and protected memories required for 5G security algorithms and secured storage of encryption keys. Additionally, they integrate advanced power-saving modes for battery-operated devices and a wide range of security features such as shields, fault detectors, and countermeasures. Compared with a removable SIM, the embedded SIM, which supports remote provisioning, is actually the more secure option for new IoT and M2M designs. The GSMA requirement for embedded SIMs also go further than those that apply for the removable SIM, covering testing and certification of the product itself, but also audits of supply chain and manufacturing processes by independent certified laboratories. Infineon meets the growing need for trust in 5G networks by offering a broad range of security controllers and Optiga Connect turnkey eSIM solutions. These solutions outperform GSMA security requirements and are certified according to the international common criteria standards. At their core is a security controller providing the robust and trustworthy vault required to protect against fraudulent use and to store sensitive keys.
Great. Thank you very much indeed, Lars, for these very interesting insights and for being with us today. That's very much appreciated.
Thanks a lot for the invitation, Andreas. It's been a pleasure.